We had scalene, no equal sides, isosceles, at least 2 equal sides, equilateral, all 3 sides equal. We had acute, 3 acute angles, obtuse, 1 obtuse angle. What do you think the other 2 angles are going to be?
Acute.
Acute, very good. Right triangle has 1 right angle. What do you think the other 2 are going to be?
Acute.
Acute, very good. And equiangular has 3 equal angles, which Darian pointed out means that they all equal 60 degrees. Very good. All right, let's move on to the next thing. Every equilateral triangle is also equiangular. If the 3 sides equal each other, then the 3 angles equal each other. And this information is good to know because if I am given a triangle, and I am simply told this, remember these are tick marks identifying segments that are equal to each other. I can say that this is an equilateral triangle, and I can give you the measures of all 3 of those angles. 60, 60, and 60. And if in this same triangle, you are given this information, you can tell me the lengths of the other 2 sides. 5 and 5. Because if these 2 angles are 60, this angle has to be 60 to make my 180 degrees, which means it's equiangular. And if it's equiangular, then all the sides are also equal. So this is 5, and this is 5. So every equiangular triangle is also equilateral. Okay? All right, what's next? We have a corollary that we need to learn. And this is what it says. It says if 2 angles of one triangle, write this down, you can abbreviate. If 2 angles of one triangle are congruent to 2 angles of another triangle,
Are congruent to
2 angles of another triangle,
Abbreviating shapes and stuff.
then the third angles are congruent. All right, now I have a picture to illustrate what this is saying.
congruent is multiple.
Yes. Okay, so you have 2 triangles. And 2 of the angles in one of them is equal or are equal to 2 of the angles in another. Look, 90 and 30, 90 and 30. What this corollary says is that if this is true, then these blue question mark angles have to also be the same. Why? Because the sum of these 3 angles have to be 180, and the sum of these 3 angles have to be 180, and in both cases I've already accounted for 120 of that 180. So the others are 60. So we've got a 60-degree angle here and a 60-degree angle here. So that's what the corollary says. If 2 angles of one triangle are congruent to 2 angles of another, then you automatically know that the third angles are also congruent. Okay? All right, the next corollary, you may have already written it down, but it says that each angle of an equiangular triangle is 60 degrees. And we've already discussed that. Each angle of an equiangular triangle is equal to 60 degrees.
Do we have to write these in our note cards?
Yes,
No.
because these are all reasons that can be used in proofs.
You never have to use this
All right, the next one says this. In a triangle, there can be, and we've already said this is common sense, there can only be one right angle or one obtuse angle. You cannot have more than one right angle, and you cannot have more than one obtuse angle in a triangle.
And you cannot have a right angle and an obtuse angle.
Right, correct. And then the next corollary of this picture is what it applies to. It says the acute angles of a right triangle are, and we're going to fill in the blank.
Congruent.
No, they are not congruent.
Equal.
The acute angles, which would be x and y, of a right triangle are
Less than 45.
Add up to 90.
add up to 90 degrees. Very good. And what's the word? Supplementary is not the word. Complementary. Complementary. The two acute angles in a right triangle are complementary.
Is that a theorem?
It's a corollary. Corollary is a statement that can be easily proved with a theorem. And how would we prove this? Well, all three angles have to add up to 180. So x plus y have to be 90.
The triangle addition, actually.
And if x plus y equal 90, then they're complements. Okay? All right, and then we have a theorem. But before we apply the theorem, we have to understand the terminology. In the picture that's drawn here, you see that one of the sides of the triangle I've extended to create an angle 4. Okay? Now on this picture I have interior angles and I have an exterior angle. Now common sense should tell you that the exterior angle is found where?
On the exterior.
On the exterior or the outside of the triangle. So which angle in here would be the exterior angle?
4.
Angle 4, okay? In this theorem it says that an exterior angle of a triangle, which would be angle 4, is equal to the sum, which means you're going to add two things together, of the remote interior angles. Now we have two words there. Remote
Interior.
and interior. Interior means they're inside the triangle. And remote means they're not touching the exterior angle. Remote. If you're lost on a remote island, that means you're far away from everything, right? So the two remote angles here would be angle 2 and angle 3. An exterior angle is equal to the sum of the remote interior angles.
It's not touching.
2 plus 3. And we're gonna prove it.
Equals 4.
We're gonna see why that's true.
2 plus 3 equals 4.
Okay. This is why. Look at angle 4 and 1. Together they form a straight angle. So angle 4 is a supplement to angle 1. True?
So supplements of something.
Okay. Angle 1, when it's added to the sum of 2 and 3, must add up to what?
180.
180.
Supplements of
So that means that the sum of these two angles are supplementary to angle 1.
substitution.
So, very good. If 4 is a supplement to angle 1, and the sum of these two angles is supplementary to angle 1, and angle 1 equals itself, then supplements of equal angles are equal to each other. So that's why angle 4 is equal to the sum of angle 2 and 3. Now do you get a better dairy? Huh?
All those angles have to be equal.
They don't have to be equal. It can be 3 completely unequal angles. Alright? And no matter which exterior angle you draw, it's going to be true. So if I extended this line and called this angle 5, you would tell